Right, good afternoon. We are continuing on waves. So we are continuing what we started in the notes. So I'm going to give you an example of a sinusoidal wave. This particular wave is a sine wave. It's number 4a. Example 4a. Y equals to 2 sine bracket t plus pi over 3. Right, it's saying sketch one cycle of graph for t is equal to or greater to 0, indicate all important points. So the first point thing is to draw the axis, which I have already drawn. You see there is y and t. There's t and y axis. The normal one, which you call the x-axis, is given in as time in seconds, and the y-axis is just the normal y-axis according to the equation, right? So the first thing that you do now, it's from that equation we can tell what is amplitude. The amplitude is 2. This is the amplitude, right? Then our angular velocity is 1 radian per second, because here it's 1 there. There's no need to write it. That's why it's just t, right? So we have those two, the amplitude and and the angular velocity, and also we have the phase or the phase angle, which is given as pi over 3, which is this one, right? Now the first thing that you do now is to draw this graph. Y is equal to 2 sine t, right? Before we take the phase angle, we draw this one. So I'm gonna use a red pen to draw this, right? For this one, remember from our properties, what is the period for this? We need to find the period, the time taken to complete one cycle. So the period is given as t is equal to 2 pi over omega, right? If you look at our omega there, again it's 1, right? Which means t is equal to what? To 2 pi. So it's going to take to complete one cycle. It's what? It's 2 pi, which means, remember, this is a sine. This is a what? A sine wave, which means it starts at 0. So we start there and draw. It goes up and down and reaches that side. Right, so the values, it is 0 there, there is pi, that's half cycle, and there is 2 pi. So what is our amplitude? Remember, it's -2, that is all, the positive is 2, right? So because that's the amplitude, which you know in there, right? So if we have these now, the next thing that you do now is to draw this graph. Now, how do you draw this graph? Already this graph has the same amplitude as that one which I have drawn, which has no phase angle or phase, right? So I know it is red pencil, but marker, but there is my first thing which we know is the amplitude is 2. So I will find the values of t when t intercepts we find the values of t when y is equal to 0. So this is called t-intercept. So the t-intercept, if you look at this particular graph for y equals to 2 sine t, the intercept when y is equal to 0, it happens there at 0 and at pi, that's a half cycle, then at 2 pi. So these three, as you can see, there is t equal to 0, t equals to pi, and t equals to 2 pi for this particular wave, right? Now, in order to draw this one, we use this equation y is equal to 2 sine t plus pi over 3. But now to get the t-intercepts, you only take this and equate it to the left hand side of these 3 points, right? So that's what I've done there. T plus pi over 3, which is this part only, which I take, which is equal to this first what value of t, where y is equal to what, to 0. So I take that to the right hand side, I get that value minus pi over 3. Then the second one again, t plus, look, I just take this again, t plus pi over 3 for the second value, which is pi. So t plus pi over 3 is equal to what? To pi. So I get t equals to 2 pi over 3. Then the third value is 2 pi. So it means t plus pi over 3 is equal to what? To 2 pi. Then I take this value, I get t equal to 5 pi over 3. Now I've got what? 3 values. So these values I put in this graph, which means this is minus, which means it's this side, right? This is minus that side, right? Then there is 2/3 of pi, which is there, right? Then I put another value there, which is the third value, which is 5 pi over 3. Right, now I've got these 3 values, but I need another value, because look, this shows from this, remember from my notes, there is positive. It means this is a lead, right? This graph, it is ahead of the one which is in red, right? It's a lead, right? Because of that positive, right? Pi over there, that phase angle, which means it's ahead. So we need to see where it crosses the y, which is called a y-intercept. So this is how you calculate your y-intercept, which means your y-intercept is equal to what? 2 sine there. You remember t, we are saying is t is 0 when at the y-intercept t is equal to 0, right? T is equal to 0 at the y-intercept. So we evaluate, we just substitute t0 in that equation, then it's 0 plus that, we remain with that. Remember, these are radians. So when you take your calculator, you see you get y equals 1.73. Then you come to this equation, to this graph, which means 1.73, it's not yet, it means 1.73 is somewhere there, right? So now I'm starting to join my point. Remember, we need to show this point. So now I join my point, like, sorry, let me do it properly. I am going to put the 1.73 after. Now remember, this graph, we are told to start at t equals to 0. So this, we only start to mark from there. Of course, you can put this as dotted there, we start there. But here, you need to continue. You need to continue up to this point, 2 pi, which will obviously will be the same value as 1.73 that side, right? We don't need to, just to show that this is where we end, right, in dots like that. That value is 1. What? Where it crosses 1.73. So that is all on this graph. Now I've drawn the graph y equals to 2 sine t plus pi over 3 using the properties.